All right, for this lesson, we are talking all about fractions that are the same size as other fractions. Anybody remember what they're called? Equivalent fractions. They are equal to other fractions. So the word equivalent, I always think kind of looks like the word equal. So that is what we are talking about today, fractions that are the same size. So here we have 1/2, and look, what's the same size as 1/2? 2/4. What's the same size as 2/4? 4/8. All ways of saying the same amount of stuff. If I said, do you want 1/2 of a candy bar, 2/4 of a candy bar, or 4/8 of a candy bar? Well, they're all the same size, so it wouldn't matter. They're all equal. Now, here are some more visually, or some examples for you to picture. So here we have, how would I write that? 1/3. And then if we look at this next picture, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so it's ninths. We have 3 of them colored in, so it's 3/9. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they are 12ths, and 3 of them are colored in, which is the same thing as right here, 1/4. Here we have 2/3. Next to it, well, that's a lot of pieces. Same number as that though. So I can see that's 1, 2, 3, 4, 5, 6, 7, 8 are colored in out of 12. So 2/3 is equal to 8/12. Don't worry, I'm getting somewhere with my point. 9/12 equals 3/4. And then here we have 5/10 equals 1/2. Now, sometimes they're not going to draw a picture for you, and you have to be able to figure out an equivalent fraction just if you are given the fraction all by itself. So how you can do that is if I have a fraction like 3/5, I can multiply the top and the bottom by the same number. So if I multiply them both by 2, I get 6/10. That's an equivalent fraction. If I had done 3/5 times 3, that is 9/15. That is also an equivalent fraction. That means these 3 are actually all equal to each other because they're all equal to 3/5. Now, if I had 1/4, okay, maybe I want to do times 5. That's 5/20. Equivalent fraction. Now, sometimes I get a big fraction like 8/20. Say, what's an equivalent fraction? Well, I can multiply it. Say I multiplied by 2 to give me 16/40. Or I could divide. So if I have divided by 2, just like we do on our calendar math, divide by 2, I get 4/10. That is also equivalent. So all of these are equivalent to one another. Now I could divide this even again, divided by 2 again, giving me 2/5, also an equivalent fraction. And because that's the smallest it can go, that's also what we call simplified. Now, sometimes they'll give you part of a fraction. So I might get, okay, 2/3 is equivalent to 4 somethings. How do I figure out what that missing denominator is? What I can do is I can think about, okay, what did I multiply by to go from here to here? Well, 2 times 2 equals 4. So then I also need to do 3 times 2 to get 6. So I know 4/6 is equivalent to 2/3. Another example, if I had 2/5 equals some number of 15ths. I don't know how many 15ths it's equal. But I can think, okay, what did I multiply by? Well, 5, 10, 15, 1, 2, 3 is what I multiplied by. So then I have to multiply the top by 3 as well, because that's keeping it equal. 6/15. And the reason why I multiply by the same number is because 3/3 is really just 1. So I'm really just multiplying by 1, which keeps it equal. Anyway, I'll do a few more examples, but the code word is team. The code word for this video is team. Now, one thing I did want to show you is I'm including a link to this on your assignment. So it can be helpful to visualize. Now, it won't work for all of them because sometimes the pieces are really big. But if I say, okay, I have some thirds, keeping in mind that that's how big a whole is. So this whole thing is not 1. It's really actually 2. But 2/3. And maybe I know it's 6. And I want to say, okay, how many 6 is equal? Well, I can place them out. And I can say, okay, if I have 2/3, that's equal to 4/6. So I can actually see it instead of just looking at the numbers. That can be helpful when you're trying to imagine what fractions mean, what they're like. Your assignment for this is a combination. So some of it is shading in an equivalent amount. So if I start with 2/6, I want to color in an equivalent amount over here, and then I name that fraction. Some of it is up here figuring out, okay, what's the missing number? The missing number tends to be a little harder, so let me do a few more examples of that. Sorry, I'm actually going to go back to here because my pen works. Anyway, so if I have 3, that's the weirdest 3 ever. 3/10 equals some number of 60ths. Sometimes the denominators get big. So I need to say, okay, what did I multiply by? Well, 10, 20, 30, 40. I'm just writing the multiples out. 60. Okay, 1, 2, 3, 4, 5, 6. I multiplied by 6. So I multiply the top by 6. So I know that 18/60ths is equivalent to 3/10. This will get really important when we start adding fractions with different denominators. Say I have 4/9. I want to know how many 27ths that is. Well, 9 times what is 27? I could look on a multiplication chart, or I could write my multiples. 9, 18, 27. Okay, 1, 2, 3. So times 3. So 12/27ths is equivalent to 4/9. All right, if you need help, feel free to ask. Good luck, you got this.